Alright, so this presentation is about creating the virtual data center on Amazon using VPC, and we will go through the fundamentals of uh, creating a VPC and walk through the steps. My name is Vijay Menon. I'm a solution architect with Amazon Web Services, and today the co-presenter with me is Mr. Bimal Shah, who is head of TCS Ion Product Management. Right, so we both are co-presenting this. So to start with the typical AWS journey, it starts off with you spinning up an EC2 instance in AWS, then you fall in love with it, and then you want to spin up more EC2 instances, right? So all these EC2 instances go and they are deployed in a network which is in AWS, but it's a virtual private cloud. That means it's an isolated network, a portion of AWS network carved out for you, and which is isolated from rest of the world. That means no traffic can get into it, or no traffic can get out of it without you making that happen, right? So in that VPC, you can choose any IP address you want. You can deploy it in multiple subnets, which ties up to multiple availability zones within a region, which I will talk about. And then you will apply some elastic IPs to some of the EC2 instances which you want to communicate to internet, and then modify the route table to have the communication going out of your VPC to internet, right? So we will go through these steps, get familiar with what are the VPC fundamentals and how do you deploy or quickly create a virtual data center on cloud which is connected to internet for your web facing applications. So the steps of going through creating a VPC is, first you will choose an IP address range. Now this IP address range can be any IP address range, but we suggest that you use RFC 1918 range, which is private IP address range, like 10 dot range, or a 172 dot range, or a 192.168 range, right? And then you would use that network and divide that into multiple subnets. You will spread it across multiple availability zones. As I said, we will talk about availability zones for high availability and management in subsequent slides. Then you would create a route table in there which will help you move the traffic in and out of your VPC based on your needs, right? And then once it's connected to internet, you would apply some security groups around the EC2 instance so that you can restrict what traffic can get into this EC2 instance, or what traffic can get out of the EC2 instance. So choosing an IP address range. So normally, we recommend that we denote the IP address range in a CIDR notation, a classless interdomain routing notation, which looks something like this, where you have IP address followed by with the slash and 2 digits. So I think most of you are familiar with it, but it's the first so IP address is a 32-bit identifier, right? So what this tells is that first 16-bit will be used for network, and last 16-bit will be used for addressing the host, right? And we recommend that you use RFC 1918 range, which is like private IP addressing range, and we recommend that when you are building an VPC, start with the /16, which is the biggest VPC you can have. Because it's RFC 1918 private address range, you don't have to worry about consuming all the IP addresses if you choose a big enough range. And our recommendation is that you look at your entire scope, let's say your corporate offices, your other data centers, and choose an IP address range which is unique, right? So that in future, if you want to connect these networks together, like a VPC and other networks, you should not run into overlapping IP address issues. Next, what you would do is you will create subnets. So before we talk about subnets, let's talk about what the VPC's scope is. So VPC is a regional construct. That means when you create a VPC, it spans across a region. For example, India region, right? And within that region, or within that VPC, you create subnets. And subnets are zonal construct. That means when you create a subnet, it will go and sit in one of the availability zone. And you have a choice of spreading your EC2 instance across the availability zones for high availability. For example, if you have web servers which are serving traffic to the customer, you can have servers spread across both the availability zones, right? And so that if one availability goes down in a rare scenario, you have another availability zone serving the customer traffic, right? So once again, the recommendation are user/16, which will give you around 65,500 IP addresses in a VPC. Within the VPC, use subnets spread across multiple availability zone, and we say you start with a /24, right, which will give you around 251 usable IP addresses, because we reserve few IP addresses there. And when you use subnets, you should spread across multiple availability zones, right? Now you have created the CIDR VPC and you have created the subnets. You want to connect it to internet. So how do you do that? So that you do with route tables. Really quick, route tables are something which will give you the rules of how traffic flows in and out of your VPC, right? What will be the next stop of the traffic when it's going out of your VPC, or if it is traveling within your VPC, right? So by default, when you look at a VPC, it comes with the default route, where the CIDR of the VPC will be pointed to a local target. That means any traffic which is destined to any other endpoint in your VPC will stay within the VPC. It won't have to go out of it, right? Then when you have to send traffic out of the VPC, you create a logical construct called IGW, which is a logical connection which will take traffic in and out of your VPC, and it will scale with your data, and then you attach it to a VPC, right? And once you attach it to a VPC, you add a default route in your VPC which will point to the IGW. That means any traffic to which the destination is not in your VPC, it will send it to the IGW, and IGW has a path to internet, right? So now you have a VPC up and running with connection to internet. You want to secure the EC2 instances so that only traffic which you allow get into your EC2 instance. So that's where security group comes, like security groups. I think if you are aware of it, you can apply it. It's a distributed firewall which you apply around each EC2 instance you have. So if you look at a typical VPC, you will have, let's say, web servers on the top layer depicted by yellow color here, and application server or database server at the bottom, which is depicted by blue color, right? And then you apply security group around each of these layer individual EC2 instance. On the web server, you say allow traffic from internet, anywhere from internet on port 80. And on the application server, you say allow traffic from just the web server, right? Not from the internet, right? And when you look at the console, you would see something like this, right? Where it says allow traffic from all IP addresses on port 80 or HTTP, right? And then you can also put a rule description there saying that, later down the line, if you want to audit your environment, you should be able to identify why this security group rule was put in, right? So it's a good idea to keep a description for every rule you put in. And then there is a concept called nesting the security groups. So if you were present in the previous talk from me, where I mentioned that you can nest security groups so that every time you make a change in one layer, you do not have to go and make changes in your security groups of the application layer. For example, if IP address in the web layer changes, right, it will automatically be reflected in the security group, the application server. Security group which is around the application server. Right, so there is some additional notes, like you should always follow the principle of least access, where that means you only open ports which you require on the EC2 instance, instead of opening up, let's say, a range of ports, saying that, okay, I don't know which port is going to be used, so I'm going to open a big range of it. So that's not recommended. Also, most of the time when you are applying rules, by default you apply it for ingress, like any traffic which is coming into the EC2 instance. You have an option to apply it on the egress also, right? Any traffic leaving your EC2 instance. So you should look at that and see what fits your use case, and then apply the rules accordingly. So now the VPC is up and running and you have traffic coming in and out of VPC. Let's talk about the connectivity options you have with the VPC, right? So what all portions of the network or where all you can connect these VPCs to, right? So you may want to connect to different part of the internet or different part of your corporate network, but you may want to restrict internet access, saying that only certain subnets from your VPC can talk to internet, some of the subnets cannot talk to the internet, right? The other thing you may want to do is connect to other VPCs, whether it's your team which have multiple VPCs which you want to connect together, or it could be your customer's VPC where you are consuming or providing services to another customer on AWS, right? The third connectivity option you may want to use is connecting to your existing corporate data centers or your corporate offices, right? So these are the connectivity option we will explore in next slides. So restricting access to internet, right? So as I said, when you have route tables, you can attach route tables to individual subnets. So in the previous example where we had yellow web servers and blue application server, you can say that the web servers require access to internet. So I will modify the route table of web server to allow connectivity to internet, whereas the application server do not require direct connectivity to internet. So I won't put any route table in there, a routing statement in there, which would let it connect to internet, right? Now, what if you need connectivity from the private subnet to internet for, let's say, pulling down operating system updates from your YAM repo or Microsoft updates, right? That means the instances require connectivity out to internet, but they don't need anyone from outside of the internet connecting in, right? So how can you achieve that? So same way you would have two route tables, one with access to internet in the public subnet and one without access to internet in the private subnet. You will deploy something called a managed NAT gateway, which is like a Amazon AWS managed NAT gateway, right, which will have access to internet, just like you do at your home network where you have a firewall which will take traffic from all your connected devices at home network and send it to internet. Then you modify the route table of the private subnet to point to NAT gateway, right? So this is how it will look like. You would see a default route pointing to a NAT gateway. Now instances in your private subnet have access to internet for whatever reason, but anything on internet cannot initiate session back to your private subnet, right? So other connectivity option we talked about is interfacing with another VPC. So why would you want to do that, right? So as I said, you could be consuming resources from your customer, or you're maybe providing services to another customer. One other reason could be that you have multiple VPCs which requires a common set of services like authentication for monitoring or logging, right, or scanning an environment or remote administration. You can put that all in one VPC instead of deploying it multiple times in multiple VPC to save cost and management, right? And then make those VPCs talk to each other using VPC peering. So what you do there is between two VPC you go to the console and create a VPC peering, and you can use like the way I mentioned nesting security group, like you use security group as a source in another security group. You can still do that, right? So which keeps with the any change in the orange security group will automatically get reflected in the security group of blue on the right side, right? And to make those two VPCs connects, the source VPC will send a request to the destination VPC, right, or the administrator of the destination VPC. The administrator of the destination VPC will accept that request, right? So it's not random, like there is some control there. You can put controls in place where these VPCs talk to each other, or how the connectivity is authorized, or only authorized connectivity should be allowed, right? And then in step 3 you have to define the route table. You have to tell each VPC that the peering is there, but how will the traffic traffic traverse between one VPC and another VPC. So in this scenario you would see that the right side VPC, which is 10.5.0.0, is accessible via the target of PCX dash a number. So that actually is a VPC peering endpoint to which you will modify a route table to point to that IP address or that endpoint, right? So this is how you make two VPCs talk to each other. Now let's talk about how to connect your virtual data centers, right, or your data centers or your corporate offices to the virtual data center. So the two options you get here is VPN and direct connect, right? So VPN by far is the most popular way of connecting to your resources in AWS from your corporate offices or your data centers. And if the internet the weather situations like variable latencies or outages on ISP is not something which your application can withstand, you can go for a AWS Direct Connect, which will be a private connectivity between two endpoints. One will be AWS, the other will be your data center. So let's talk about the VPN basics. So as you know, your data center will have a edge router which will be connected to internet. We call it customer gateway, and you will deploy a virtual private gateway on in your VPC, right? Once you do that, using that customer gateway, you will create IPsec tunnels from the AWS console. By default, we create 2 IPsec tunnels per customer gateway for redundancy, and recommendation is you configure both the tunnels and keep it up and running, so that if one tunnel fails or one internet connection fails or one portion of the VGW fails, you have redundancy there, right? And then you will modify the route table, where you will tell the route table of your VPC that if it needs to connect to the remote endpoint, it will point to the VGW. So as I talked about the dependency between variable latency and jitter which you get with internet, if your application is not able to withstand that, you can use direct connect. But there is another advantage of direct connect, where the data transfer out charges are significantly lower as compared to the data transfer out charges you will get with VPC, right, or IPsec VPN. So based on your requirement and based on the amount of data you transfer between your VPC and rest of the network, rest of your corporate network, you should be able to make a decision whether direct connect will be economical or not, right? So that was like the basic VPC with some EC2 instances running, connecting to your data center or your corporate offices. So what about other services in VPC, right? So if you look at the VPC, you get DNS, right? You get services like RDS, Lambda, and you get services like VPC endpoint, and then finally monitoring, right? So let's look at what exactly is that, right? So DNS in a VPC. So what that means is, in a VPC you can configure the EC2 instances and your network to use Amazon provided DNS server by choosing DNS resolution and DNS hostname options to yes when you're creating the VPC from the console, right? Once you do that, it will use Amazon DNS server to resolve the IP address, resolve the host names you want to connect to, right? At the same time, it will assign a host name to each EC2 instance you provision in your VPC. Right? And then you can also create a private hosted zone. So this gives you ability of split DNS, where for the name resolutions within the VPC, you can use the Route 53 private hosted zone, and for anything outside your VPC, you will use Amazon provided DNS, right? So that's really easy to provision a DNS and have a name resolution going on in a VPC when once your VPC is up and running, right? So talking about other services of VPC, I'll talk about the most popular one, which is Amazon RDS, Relational Database Services, which is like a fully managed database, relational database services provided by us. So in a VPC, you would have EC2 instances running and a database running. You will apply the security groups we talked about, and then you will enable, you can enable RDS multi-AZ. So this is where I was saying that you can spread your workload across multiple availability zone for high availability, right? So in this scenario, the RDS in the left VPC will automatically sync up with the RDS in the right VPC, database instance in the right VPC synchronously. And that EC2 or the RDS endpoint will be accessible over a DNS name. So when the failover actually happens, you don't have to go and make changes to your application to point to a new RDS endpoint. That will be taken care by managed RDS services by default. So other popular services, elastic load balancing or application load balancing, right? So what you can do is you can place the load balancer in a public subnet like we talked about, and it can spread the incoming traffic onto multiple EC2 instances spread across multiple availability zone, right? And so this just depicts that, you know, whenever the traffic comes on the ALB, it spreads it across multiple web servers, spread across multiple availability zone, right? So this takes traffics in and out. You deployed a database server. Now, what if you need access to, you know, S3 bucket or objects in your S3 bucket that lies in the outside the VPC, right? So in a normal scenario, what you would do is you will have your applications running in your VPC and your data in S3. To access that, you will provision an IGW and you will modify the route table to point to the IGW for going to S3. So in this scenario, the traffic is leaving your VPC, going on to the public side of the network and getting into your S3 bucket. right? May not be well, both of it's on the same network. Why can't we do it over a private network? So we did exactly that. We came up with the option of using VPC endpoints, where you deploy a VPC instead of using IGW, you replace it with the VPC endpoint. Now you can communicate with S3 bucket or DynamoDB using private IP addresses, and your route table would look something like this, where it will have S3 or DynamoDB prefix list, right? So IP, which is nothing but a list of IP addresses which defines the endpoints of S3 and DynamoDB and pointed to a VPC endpoint, right? So the other, now the option you see there is advantage you see there is, with the VPC endpoint you can deploy IAM policy on the VPC endpoint, and you can control access to your S3 bucket more granularly on top of what S3 bucket already the resource policies on S3 bucket already provides, right? Another type of connectivity out of your VPC would be interface endpoints. That means if you have a AWS service like EC2 API or a supported AWS service like EC2 APIs or KMS API, you can deploy AWS private link endpoint in your VPC. So let's say this is the VPC which wants to talk to EC2 APIs, which is outside the VPC. You will deploy a private link, and it will appear as a internal IP address in your VPC. That means your VPC don't need IGW or connectivity to public network to access the EC2 APIs, right? And it will all these endpoints will have, each endpoint will have multiple host names which will be mapped to the EC2 API endpoint name using a CNAME in Route 53, right? So this is about AWS services. What about services hosted by someone else, right? Or another business unit of your organization or another team of your organization? You can use the same thing using deploying the services behind a network load balancer and then creating a VPC endpoint in your private VPC, which will again get an endpoint name which you can map to using a CNAME, right? So what happens is the endpoint which is hosted in the remote VPC of your customer or of your another team of your organization, that appears as a private IP address in your VPC, right? So the security posture improves. You don't need to provision connectivity between two VPCs, maintain the routing table. You can always use the private link to establish that. Now all that said, your connectivity is there, everything is working fine. In a traditional data center, you always have monitoring where you keep looking at the traffic which is leaving your data center or which is coming into your data center. How do you do that in AWS, right? So the answer is VPC flow logs. So what VPC flow log does is when you enable VPC flow logs, you can enable it on a EC2 instance ENI. You can enable it on a subnet in a VPC, or you can enable it for the entire VPC itself, right? Once you enable it, it's going to start sending the VPC flow logs to CloudWatch, right? And it can be used for troubleshooting purposes, or if you want to analyze traffic, or if you see how your application is behaving on the network, you can use these logs to look at, right? So this will, and you can do that from your VPC's console. You can go and click on flow logs tab, and there you can go and say create flow log, right? So it will create a flow log. It will give you a ARN for that, and it will start sending that flow logs or the network traffic into CloudWatch, which will look something like this. So once you enable VPC flow log, you can go to CloudWatch, right, and then start looking at your traffic. So for example, if we dissect in one of the statements, you would see, let's say this one, you would see that the traffic was accepted by the security group, right? The port, source port there or destination port there was TCP 443, so that it's an HTTP, so you know it's an HTTPS traffic. And then it will also give you the source IP address and destination IP address. So you can, if you get the source IP address, you can run DNS resolution or a dig command or a NS lookup command to find out where the traffic is coming from, right? So that covers, like in a very compressed time frame, how you can create a virtual data center on AWS.